Assalamu alaikum wa rahmatullahi wa barakatuh. For this session, we will start with the cardiovascular system. We will continue with the cardiovascular system. We finished with the heart, and now we will transfer to the blood vessels. We said that the heart, it is the engine, and which has the power, which pump the blood all over the body in order to transfer the blood, which is rich in oxygen and nutrient, to all body tissues. We said that also the blood vessel, it is the road that the blood is passing through in order to reach each cell within our body and to supply it with its demand with the oxygen, nutrient, and also to take from it the waste product and the end product of the metabolism in order to excrete it outside of the body by the excretion system, either by the kidney or by the skin or by the respiratory system. So the blood vessels system, we said that it is the road that the blood is passing through and going through. It's pumped into, the blood is pumped into a large artery, leaving the heart into smaller artery. So if we are taking the type of blood vessels are divided to three types. The first type, which is the artery. The artery, it's carrying the blood from the heart to the body system and to the whole body. Then there are smaller artery. So the main artery is there, then a smaller artery, which is the arteriole, it's called the arteriole. Then it will end, those arterioles, it will end with a network of capillaries. The arterial part, in that arterial part, or the network of capillary, in that part, there will be the exchange of oxygen, nutrient, and taking the waste product from the venous part. So then from the venous part or site of capillary, it will go to venous, then to vein, then to the main veins, and to the vein, which is the vena cava inferior and superior, in order to go back to the heart. So three types of blood vessels: the artery, the vein, and the capillaries. So the blood, as we said, it's pumped into large artery, leave the heart, the blood is pumped into a large arteries, leave the heart into a smaller arterioles, and the arterioles, which is the smallest arteries, feed the capillaries bed in the tissues. Those are the capillaries bed in the tissue, and here most of the exchange, it is done here, either supplying nutrient and oxygen, and taking from the venous side, taking the waste product from the tissue and carbon dioxide. Capillary beds are drained by venules, which is the smallest vein, which empty in a vein that finally empty in vena cava, either superior or vena cava inferior. So again, the blood is coming out from the main artery, from the aorta, then going to a smaller arteries, which is arteriole, then it will go to the capillaries inside the tissues, and here the exchange will happen. The part of the venous part of the capillaries, then the venules, then the small vein, then the main vein, which is vena cava inferior or vena cava superior, that will return back the blood to the heart. The blood vessels, so again, as we said, we have arteries, arterioles, capillaries, which is divided to two parts. It is the arterial side and the venous side, which is inside the tissues, and the main exchange done inside it, venous and veins. So if we are taking a section from the artery and a section from the vein. So vein and artery similar in one thing, that they are having 3 layers. But the vein is having, the main veins or large vein, they are having valves. But there is no valve either in the arteries or on the capillaries. So there is no valves in the capillaries and in the arteries. So the 3 layers of the artery and it is, or the 3 layers of the blood vessels, it is the tunica, intima, which line the lumen. So tunica, intima. Intima, take it from inside. So it is a thin layer of endothelial squamous cell epithelium. That thin layer, the function, it is a smooth layer, so it provides smooth and it will prevent friction between the blood and the wall of the blood vessels. So it makes the movement of the blood inside the blood vessels to be smooth and not to have any friction. That the friction, it might lead to crashing of the blood cells. So it is very smooth and it might lead to adhesion. So in order to prevent adhesion or destruction or hemolysis, it is a very smooth layer from interior. Then the tunica media. Tunica media, it is the middle layer of the artery and vein. So it is consists from smooth muscle and elastic fiber. The function of it is to control, and it is controlled by the sympathetic nervous system. Function, it is change of diameter of the lumen, especially in the artery, in order to maintain the blood pressure also. So it will change the diameter or of the artery in order to suit the amount of blood that is passing inside it. Then we have the tunica externa, which is the external layer, which is mostly fibrous connective tissues. That fibrous connective tissue, it is supporting the artery and the vein. It is supporting the blood vessels and protect the vessels. So it is for the support and protection of the blood vessels. So again, tunica intima from inside, which is endothelial tissues, and it is very smooth layer. Then we have the loose connective tissues, tunica media, which is smooth muscles, which has smooth muscles, and it will control the diameter of the blood vessels. Then tunica externa, which is of a collagen fiber, and to protect the blood vessels. So those 2 layers, it is present in the artery and the vein. But the difference, we will see the difference of them. About the capillaries, it is composed from only one layer in order to help in the exchange of or oxygen, in order to help the oxygen to go out and to help the nutrient also to go out to the tissues and be supplied to the tissues, and also in order to let the exchange of gases, the oxygen and carbon dioxide, and also waste product, and all elements within the body in order to maintain normal level of those elements. So it is basement membrane and endothelial cells. So it is of one layer. Now the structure and function comparison between the artery, the vein, and capillary. So if we are taking the lumen of those blood vessels, the lumen of the artery is a smaller lumen in order to maintain the pressure and maintain the force of pushing the blood toward the blood cells. The lumen of the vein, it is more larger in order to let the backflow of blood to the heart. The lumen of the capillary, it is very small lumen. So in order to have to slow down the movement of the blood, and in order to have the ability to exchange of nutrient and also the gases and all elements between the blood and the surrounding tissues. The function of the artery, it is to carry away the blood from the heart to other parts of the body, to all parts of the body. And as we mentioned, carrying the blood is carrying with it the nutrient and carrying with it the oxygen and minerals. So the vein, it carries blood to the heart, from the body to the heart. The capillary, it connects the artery and the vein. So it is connecting the artery and the vein, and all the exchanges happened in the capillaries, inside the tissues. So the capillaries bit, it is present, or the network of capillary, it is present in the tissue, and all the exchange, it is happening inside those tissue, between the tissue and the capillary, which is present there in the tissues. About the size of the lumen, as we said, the size of the lumen for the artery, it is small. The size of the lumen of the vein, it is large. The size of the lumen of the capillary, it is minute, a very small size. So it is a very small size. About the thickness of the wall, for the artery, we know that it has a high pressure, which is due to the force of the heart, and in order to help the blood to be pumped to all parts of the body. So the pressure inside the thickness of the wall, it has to be more. So the wall is more thick in the artery, and it is more elastic also, because if it is not elastic here, it will lead to high blood, the pressure will be very high, and it will lead to high blood pressure. So the wall, in order to tolerate the exerted pressure by the blood, it has to be thick. So the muscular layer in the artery, is thicker than what is in the vein. So the tunica here in the vein, it is less elastic, and also it is thinner. So it is thin and less elastic in order to, because here the pressure in the vein is low. So it doesn't need the thick wall. The capillary, it is a very thin, it is one cell layer. Why it is like this? It is a very thin layer in order to permit the exchange between the tissues and the blood. So that very thin wall, it will let the active exchange between the blood and the tissues in our body. About the blood flow, in the artery it is very fast and it is of a high pressure. In the vein it is slow and the pressure is low. At the capillary it is very slow and the pressure also is very low. So the slowness of the passage of the blood and the low pressure, it is in order to let the exchange process to happen there within the tissues. About the type of blood which is carried by those blood vessels, in the artery it is oxygenated blood. So except for the pulmonary artery. So the pulmonary artery, they are taking non-oxygenated blood from the right side of the heart to the lung to be oxygenated. The vein also, it has deoxygenated blood except for pulmonary vein, the pulmonary vein, they are having oxygenated blood which is coming back from the lung after oxygenation. About the capillaries, capillaries, they are having the arterial side, they are having oxygenated blood and supplying it to the body cell, bringing back the deoxygenated blood from the body back to the heart. So there are the oxygenated blood is there in the arterial side, and the deoxygenated it is in the venous side. About the presence of valves are present only on the vein. So arteries and capillaries, they are not having valves. So valves is there only in the vein in order to help the blood to go back to the heart and to prevent the backflow of the blood and stasis of blood in the lower part of the body. So it will help in return back of blood to the heart. So this is the artery, this is the vein. The vein is having valves. The lumen is larger, the lumen here is small. Both are having 3 layers, except here the capillaries, it has 1 layer. The tunica intima, the internal layer, which is the smooth layer. The tunica media, which is the muscular layer. The tunica externa, which is fibrous tissue and protecting the blood vessel. So the factor that promote and enhance the venous return of blood to the heart. So veins are modified to ensure that the venous return is equal to the amount of blood pumped out of which is the cardiac output. So the amount of blood which is coming in, it has to be equal to the amount of the blood which is pumped out through the aorta. So the lumen is large in the vein here, and the large vein have valve to prevent the backflow of blood and to prevent stasis of blood in the lower part of the body. There is also something, two processes that help the blood to come back other than the valves. One of them, we call it the skeletal muscle pump. The skeletal muscle action, our movement of the muscle, it will squeeze the vein and it will let the blood to come back to the main vein and to go back to the heart. And also we have what we call it the respiratory pump, which is the expansion and relaxation of the lung, which also help the blood to come back from the lung through the pulmonary artery to the left side, through the pulmonary vein to the left side of the heart. So it will let the pulmonary pump, it will let the blood which is there in the lungs to go back through the pulmonary vein to the right side, to the left side of the heart. About the skeletal muscle that's surrounding the blood vessels. So the vein here, which is going to the heart, we said that it has a valve. Those valves, they will prevent the backflow of blood to go back in the vein. So it keeps them to go in one direction toward the heart. So when the muscle contraction is there, it will lead to also pushing the blood up, open the valves and let the blood to go back toward the heart, and then the valve will, when the muscle relax, then the valve will close and it will let the other part from the lower part of the body to go out. So the blood is squeezed, or it is like milking. So it's milked through the veins toward the heart. So it will be milked out in order to go back to the heart. So the contraction of skeletal muscles and the valve opening and closing, it will lead to the one-way that the blood will go back to the heart. So venous valves and muscle pump, both of them, they will help in the return back of the blood to the heart. So those are the proximal valve will open, skeletal muscle will contract, then the distal valve will close, and the vein use the milking action of the muscle to help to move the blood toward the heart. So that will help the contraction and relaxation of the muscle. It will help to squeeze the vein and release pressure from it. By that, it will help in the emptying the blood to go toward the heart and refilling of the blood from the distal part of the body. Respiratory pump also, it has a similar action. So during inhalation, the pressure in the thorax it will be dropped. So a large vein near the heart expand and will be filled with blood. So the cardiovascular, by that action, the relaxation and the inhalation and exhalation during the expansion and contraction of the lung, this also will lead to change in the pressure within the blood vessels, and it will lead to squeeze out the blood vessels and return back of the blood from the lungs toward the pulmonary veins, and it will go back to the left side of the heart. And by that, the blood, it will be going in its circle continuously in our body. So pulmonary circulation, the return of blood, it is helped by what we call it the respiratory pump, and the body circulation of the systemic circulation, it is helped by the valve. Both are helped by the valve, by the way. It's helped by the valve, and it is helped by the muscular pump. So by that we are covering this objective. Next objective, it will be the identify of the body major arteries and veins and the body region supplied by each, and also discuss the unique feature of the cerebral and hepatic portal circulation. So this we will be discussing it in the next chapter.